Good morning, everybody. We are going to start in a couple of minutes, so let's just wait for a couple of more colleagues to join us. So we are having quite a great day here in Brussels. Unfortunately, we have a quite decent turn up in the audience, but we also know there's a number of more colleagues that are going to join us. So we are just going to start in 1 minute from now. If you would like to grab that quick coffee before we start, please do so. And let's then kick off in 1 minute from now, because we have packed agenda. We have a lot of experts with us today, and it's going to be a very interesting discussion. But we need you active. That's why coffee is imperative. Okay, I think now is the time to start. Welcome to everybody to this fantastic webinar that we are going to have today ahead of us. My name is Željko Jeftić. I am Deputy Director of Innovation and Deployment at ERTCO ITS Europe, and we are one of the proud members of the ENSEMBLE project. Today we are going to have a webinar where we will present our best work, our best findings that have happened over the lifetime of the project. The project itself is nearing its end, so this is also a great opportunity for all of us to learn about the latest results, but also to debate them as well. And this is why we have a great gathering of the key experts from the project that are going to be able to help us with communicating all of the achievements when it comes to standardization, communication channels, what we achieve as the impacts, and everything else. I would not like to take too much time because this is going to be a packed agenda. I would just like to highlight that this webinar is going to be recorded. Both webinar and including the chat as well is going to be recorded, so please be aware of that. We are not going to use it for any malicious purposes. Of course, everything is in accordance with the GDPR, but we need to make you aware that everything is being recorded, basically. We would also encourage you to use the functionalities to send us the questions anytime during the webinar. We are going to see when it is most suitable to actually ask those questions to the experts. And in the end, as it sometimes happens, if we run out of time and we don't have possibility to ask all of the questions to the experts, believe us, we are going to come back to you with all of the questions in a written form, questions and answers in a written form. That said, I would just like now to welcome all of the panelists and speakers to join me on camera, so that I can also introduce you the fantastic experts from the project. Of course, we start with Marika Hodmaker, and apologies, I will skip pronunciations of family names because they can sometimes be tricky. Marika has led the project in a fantastic way up to now, and she's also the driving force between the success of the project. Hello, Marika. Then after that, we are also having Eduardo, who is with us from Klepa. Eduardo is going to be talking to us about functionalities, about specifications, and he's also going to be, he's also working very closely with Jost as well from NXP. And of course, we all know that NXP are absolute communication experts, and this is also why we are blessed to have them with us in the project. Then also we are going to be talking about the technical implementation, and there, trust me, we have the firm and solid hand of our Delia from TNO, the best technical coordinator I've ever seen in any projects. Honestly, I'm slightly biased, but that I have the privilege to be biased as a moderator. Very quickly, we also go over to Franziska. Franziska has been responsible for the impacts in the project. And two more colleagues to present are Katrine, who you cannot see, unfortunately, because her camera is not working today. But Katrine, we know that spiritually with us today and via with the voice. And Peter Schmitting as well, another colleague from Ertico, who is going to be helping us and speaking about standardization. There's a number of people in the background helping us to organize this event. Thank you very much, Milica, and thank you everybody else who has supported this webinar. Without further ado, let's jump into the topic. Marika, the word is yours. Please tell us about the project, and we are going to have a fantastic discussion. Thank you very much.
Thank you, Željko. Thank you. Yes, I will try to give you a brief overview of actually the fantastic day that we had in Spain on September 23 with our Ensemble project. On that day, we not only showed the real platooning in real life, but we also shared with the audience there a lot of the results that we achieved so far. And since not all of you were able to be there actually in Spain, this is a chance to catch up, and I'll try to summarize the whole day in about half an hour, which is a bit tricky, but I'll give it a best shot. So let's start with the work. That's Ensemble. What is it that I will be sharing with you for today? Well, I have a brief introduction on the project, what it is about, the goals, etc. And then I will talk about some of the things that we did in a bit more detail, but of course, always not enough detail because there's a lot more in deliverables. I'll talk about the specifications and the communication protocol of the Ensemble platooning. I'll talk about a bit about the technical implementation, also on the studies we did on the impact on infrastructure, and then give you some insights in what we did with regards to standardization, because Ensemble also made quite some inputs to that work in Europe as well. So I'll start with the video because that explains much better what the project is about in just a couple of minutes than I can do it, and then I'll take it up from there. So let me share that video.
Multibrand platooning, a reality in Europe. For the first time in the mobility sector, trucks of 7 European brands are platooned together in real-life traffic conditions. This is the result of the EU co-funded project Ensemble. Started in June 2018, Ensemble is a 4-year collaborative effort aiming to ensure higher traffic safety on European roads. Truck platooning is the linking of 2 or more trucks in convoy, using wireless connectivity technology and automated driving support systems to support the drivers. Ensemble brought together the major European truck manufacturers and partners to implement their platooning systems and to test in real-world traffic conditions. On the 23rd of September, 7 trucks of leading European brands drove together during 3 hours. The trucks platooned around the Barcelona region through various traffic conditions: busy traffic, rain, tunnels, and even traffic jams. The basis of this achievement is the specifically developed V2V, vehicle-to-vehicle communication protocol. It supports the correct behaviour and reaction of each of the trucks in the platoon for every envisioned traffic use case.
So the main challenge in this project was to develop an inter-brand V2X protocol, so wireless protocol, which allows to communicate between different brands. And I think this is the main success of the project, that we achieved it.
The most exciting part is the collaboration with all of the partners throughout all the meetings, workshops, and of course the demonstration, because we can all learn a lot from each other and strengthen ourselves through these collaborations and end up with a better end result.
So as OEM, we participated to the main work packages, so starting from the definition of platooning, so levels, how the maneuvers should be, how the platoon, the convoy should look like, and then to the implementation and to test.
So Scania's role in the ENSEMBLE project is to develop a V2X and platooning platform to be able to platoon with all other brands here at ENSEMBLE.
The output is a common solution, ready for further standardization, using secure wireless communication to create a safe interaction within the platoon and with other road users. Truck platooning technology is a significant step forward to fully connected automated driving. It supports improvements in traffic safety, fuel economy, and improvement of logistic efficiency.
Us in the Volvo Group, health and safety is our core values, and today we have been, in this project now, we have been making a huge leap forward when it comes to bringing the vehicle-to-vehicle systems towards their deployment in the truck world in Europe.
Reducing the environmental impact of transport and increasing safety up to close to 0 fatalities by 2050 are some of the pressing current challenges across the EU and globally. Multi-brand platooning is a significant step forward to fully connected automated driving. This will increase transport efficiency, lower air pollution and noise, and will enhance traffic safety by reducing accidents and health impact. ENSEMBLE contributes to the standardization of interoperability between trucks, speeds up actual market pickup across Europe, and enables harmonization of legal frameworks in the member states. ENSEMBLE, together a reality. Multi-brand platoon.
Excuse me, I almost started it again, but let me switch back to my presentation now. There we are. Okay, so you heard a lot already, but in general, we can say that the main objectives of the ENSEMBLE project is actually to pave the way for the adoption of multi-brand platooning in Europe. So making the step from monobrand to multi-brand. And we do this mainly by aligning and working on those specifications, the multi-brand specifications, to implement it as a support function. I will come back to that. And to demonstrate it, of course, you've seen already some in the movie, and I'll show you later some more movie material on the real world driving. And we will assess the impacts of multi-brand platooning on traffic flow, business models, driver behavior, and fuel economy. So there's 3 green dots there already. So that's what we already did in the project. The last one, still to go, we're working on it, and we will be able to present the more details of the impacts in our final event, which will take place in March next year. And why would you do that? That's always a question, I would say. It's because we can do it is not the only reason. We expect, of course, to have quite some benefits in the end when multi-brand platooning is really happening on the road. So first of all, you can expect an improvement of traffic safety, because the safer distance that the trucks are driving behind each other in controlled conditions, instead of a distance to the truck in front based on driving on the behavior of the driver. There's a faster reaction to potentially dangerous braking situations because of the V2V communication. And there is a possibility for the controlled braking maneuvers between all of the trucks in the platoon. You can also expect an improvement of traffic flow because of a more stable string of following trucks. Again, because of that important V2V communication. And you can also think about having that standard communication protocol also not only between all the trucks, but also between other roads users on the road to have even more better influence on traffic flow. And the last point here is that it's a very important step to start with the V2V validated specifications, because they will be standardized across Europe. That's the idea. And it's a necessary step when you want to look further and develop further ahead towards autonomous platooning. The main achievements, because, well, the project has been running for 3 years. I think it's quite a lot. And in this presentation, I will share some of you with it. But mainly, I would say we start with the public demo on the real roads in Spain. And I'm really proud that we really did this. It showed that we could do it, that it's working after all those hours of aligning together in meetings, and working behind our computers on specifications and how we are going to do this together with all the main stakeholders in Europe. And then, of course, we did lots of hours of testing before we finally went to that public demo in Spain. First, mono brand, see if it works. Duo brand, 2 different brands together, 3 different brands together. And at the end, we had 7 brands in a platoon having this working together with the same implementation. And there is, of course, a lot of deliverables produced in all of this work, which are most of them are publicly available in our website. And, well, in general, we've showed that it now works in real life. So that was the general introduction. And now I'd like to tell you something about the specifications, a bit more detail on how that works with the communication protocol. It starts with a short explanation on the difference between 2 levels of platooning, the support versus the autonomous platooning, or the support versus the autonomous function. As you can see here in this nice table, when you look at platooning as a support function, the driver in the truck, in every truck of the platoon, is still responsible in the end for a safe driving behavior of the truck, behaving safely in traffic. So he's there and he's responsible, but he's supported. He has longitudinal support. He has, which means that he can take his foot off the gas pedal, of course, and the truck in general is supporting him with distance and speed keeping. There is a coordinated braking between all of the trucks in the and speed and gap keeping between all the trucks in the platoon. And there is a distance, which we here say in time headway, between the trucks of around 1.5 seconds. And I think this is important to show that it's a distance which is big enough to have the driver responsible for his task. So as soon as something happens that the support function for some reason cannot handle, a very harsh emergency braking, for example, then there is still enough reaction time left for the driver to react and make sure that he can take his responsibility that he has legally to drive safely. And I think that's one of the main differences with platooning as an autonomous function, where you can take the driver out of the loop, which means that he's not the end responsible anymore. Out of the loop does not necessarily mean he's not in the truck anymore, but at least he's not the end responsible. And that means that you can go back to very much shorter distances between the trucks, because you do not have to take into account a reaction time of a human driver to take over. So it's safe by design to follow closely, because there's no driver involved that needs to take over. So the first one, the support function, we foresee it's possible to have a quick deployment on the road, and the other one, we foresee first to have it in confined areas on the roads or specific roads, and it takes a bit more time to have it on the public roads. In the ENSEMBLE project, we had this demonstration with the support function, mainly because of the reason that it's still not allowed to have the driver not responsible. There's also legal ways. And as we say, there's this quick deployment possible, and that's also what we showed. It is possible already now on the current roads. But the specifications, I should not forget to say that, will also be made in the ENSEMBLE project for the autonomous function. So how are we going to do that with the specifications? Then let me tell you quickly about these platooning layers, where you can see actually maybe going from bottom to top, that when you see the trucks here on the road, there is always this, what we call the operational layer, the lower part in a truck, which is very OEM specific. So the truck manufacturer makes his operational layer as he likes it to make it. So he doesn't have to share this with all the others. It's like so a DAF stays a DAF and a Daimler stays a Daimler truck. That's in that operational layer part. But to be able to drive together in a platoon, you need a common part, and that's what we call the tactical layer. That's where it's common, and that's where the communication, the standardized communication, takes place between the trucks. And then, of course, there's also a higher layer to organize the platoon. Where and how is it going to drive? How long is it going to drive? Who's driving with whom? In which order? It's called the strategic layer, which can interface with a number of services provided for that in the cloud. You can say that you can envision a lot of services that make it happen, that trucks come together on the road, that they depart again on the road, that they find each other, that they navigate to the same destination. So this is the idea of the different layers, and that's also the basis, the concept of the ENSEMBLE project. So in the support function, we started as a starting point with the normal ACC, adaptive cruise control, also to comply with the current regulations. And on top of that, ENSEMBLE added the V2X communication part. So it's much more now in the end, because we realized this, than the normal ACC, because we have the earlier notification of emergency braking due to that V2V communication being much faster than an onboard sensor in a normal ACC. There is a platoon coordination, a cohesion control between all the trucks in a platoon. We make sure that there are limited speed differences. They're almost the same actually when you drive together in a platoon. We have better shockwave damping, and we have roadside information, so the infrastructure to vehicle communication. So the platoon can pick up the messages that are broadcasted by the infrastructure, which leads to more comfort, less stress for the driver, who, as I said, was always responsible. And the technology for that communication, it's at this moment ITS G5, but it's actually more what we call technology neutral. So at the moment, G5 is there everywhere available on the roads. The protocol is still available and possible to work with the 5G, sorry, with the 5G. And the difference between the cooperative adaptive cruise control is specifically the set of messages that are specifically designed for the platooning functionality. So it's not what you already see on the road in some cars or being developed. It looks like it, but this is specific platooning functionality. So it's not the same as just CACC. So for platooning, you need 3 simple phases. It starts as an individual truck that you need to engage in a platoon. You're individual and you need to join in an existing platoon or form a platoon with one other truck. So this is important because in these phases, you need your different types of communication. So the first one, of course, is to engage in the platoon, join as a single vehicle, then merge in between as a single vehicle is also possible. And so here is where the communication, so you are alone, no communication, and then you establish the communication when you have engaged. Then you have the platooning phase. Then we have looked in the project to different situations, what can encounter or use cases for that platoon, like emergency braking. A cut-in of another vehicle is a very normal, regular use case that we needed to take into account, of course. And then at some point, you need to leave the platoon or disengage the whole platoon in total. So it can be a leave or a split as we considered it. So these are the different phases that we looked at and that we needed our different ways of how to communicate that. So that's what it says here. So this is the communication that is there in all of these 3 phases that we developed in ENSEMBLE. So starting with engaging in a platoon, finding one, and if you found one, publish or broadcast your platooning capability as a truck. That's where we use the @sea cam message for. Then a relation is established, create a platoon or join an existing platoon, and you can send a request, and then the truck that is to be joined sends a response to that request, either accept or decline it. And that is done with the use of the new platoon management messages, PMM, we call them, a join request and a join response from the other truck. So that's all in the phase of how to make the platoon. And then during the platooning itself, you want to keep the platoon intact with the specific distance. So for that, you need to broadcast control information as being a truck. And for that, you use the PCMs, the platoon control messages on your position, the configuration of the whole platoon, what is your status, and numerous other control parameters. And in the last phase, in the disengaging, because you first want to increase, to do this safely, you want to increase the distance again. And at the moment you're at the safe distance, then the control is given back to the driver. So then he's not supported anymore. But the use of these PCMs is there until that bigger distance is reached and when the driver is there driving unsupported again. In all of these communications, you also need to have a look at security, because it's communication, it's public there. And so we spent also a lot of time to do this in a secure way. And there's 2 aspects to that. There is message signing, the signing of the messages, which is already common in the @sea messages, because you can authenticate in that way the message, that it's not changed, and you can see if it's coming from a trusted vehicle and not from someone else just standing besides the road, for example. But what is new in platooning is that we also use message encryption. We use two ways. We call it the asymmetric encryption and the symmetric encryption. So asymmetric is used when joining a platoon. So you can, at that moment after joining, you can create a shared key that only the two of you or the three of you or the four of you understand. And that key is then used in the symmetric encryption when the platoon is active, but it's your own specific key at that moment. This is all implemented and working at this moment, as we have also shown in the public demo. So what are the next steps? A bit of an outlook. As I already said, this was this platooning as a support function, and already in the ENSEMBLE project, we make an outlook to that autonomous platooning. So in that autonomous function, and we will tell you much more about that in the final event, the first truck is for sure driven by a human, but the following trucks could be a truck with the driver out of the loop, as I already said, manned or unmanned. The strategic layer, as you remember, the top layer will support specifically that platoon organization. Already probably in the support function, but it's even more important in the autonomous function, as you might not have a driver to organize and to say, hey, there's a truck I want to platoon with. It needs to be done automatically. So the V2X to anything connectivity can be used as an enabler for the follow me functionality. And we also foresee the hub-to-hub implementation. So, and there you can also, because it's a specific route, hub-to-hub, you can also have more interaction with intelligent infrastructure. And the time gap, as I already said, can be reduced significantly. Because the braking performance estimation functionality will support the selection of the correct time gap at that moment for safe platooning, even though it's a short distance and even though there's not a driver or maybe a driver doing something else in the following trucks. And specifically when you're looking at the shorter time gaps, then you can also look at a potential of fuel savings thanks to those short time gaps. At the moment with the support function, they might be there, but not as significant as we expect them to be when you go to the autonomous function. So a quick step then to, this was the theoretical work, how should it work? And then we also looked, of course, we did a lot of actual implementation together with the truck manufacturers in the project and with the automotive supplier partners in the project. So they actually made this reference implementation, also coordinated by TNO, that they can all use or make sure that all the trucks have the same common functionality. For the tactical layer, as I explained in the first picture, that's where all the trucks need to be able to understand each other. So that's where they need to have that common functionality and common language. So we made this reference implementation that each of the OEMs could implement them for themselves. And they did. And then, of course, you need, when it's implemented, you need to verify whether the specifications and requirements actually work. And as all of you might know, you might think of a very good way on the table, but after implementing, a lot of things at that moment still need to be updated, need to be tuned. So there is a big review, and there was also a lot of alignment work in the implementation phase. And that means that there is also a feedback loop to update the specs that we made sitting on the table. And then we had the trucks that were implemented or that were implemented in this way. So they were equipped, the trucks were all equipped. The the functionality was designed at that moment, and it started at that moment with monobrand testing. Then, as I already said, we did the 2 brands coming together, 3 brands, and at the end, you can call it multi-brand testing. So this was a big part actually of the project. And to be honest, it was during the 2 years almost that we had in the Corona time. So it made it also an extra challenge to come together with duo, triple, and quadruple brands somewhere on a test track, because it's not working from home, and it also involves traveling a lot. You cannot implement and test just sitting behind your desk in the end. But I'm glad that we were in the end able to do it. We did a lot in the COVID times. So you can see here an overview of all the test tracks that we came together in different countries in Europe, in Sweden, in the Netherlands, in Germany, with the different combinations of all the brands. A lot of times we had to postpone or cancel an agreement that or a reservation for a test track that we already made. But luckily, in the end, we were able to postpone it and not totally cancel it. So then we had another chance to do the tests after all. Then one slide on one impact study, because the project looked, for example, on the impact of platooning on the infrastructure. And because I think it's a very important, its impact, trucks on roads impact the infrastructure anyway. So the background here is that a main proportion of the road is already heavily damaged. The study was done in France, so this is the figures here are an example of France, and that you need to realize that infrastructure is not that easy or fast to repair. So actually it takes on average 22 years in between the first damage signs, as you can see here in the pictures as an example, and the actual repairs. So keeping track of the way the roads are damaged and how fast or how slow is very important, and truck platooning can have an impact there, because the parameters that are here, the gap distance, it's controlled in the platoon, and knowing that the gap distance impacts also the way the road is used, or in the end damaged, you can, when you have platooning in your future vision much more on the road, you can also influence that also for the better for your infrastructure. You can also influence, as an infrastructure owner, the driving speed of the platoon. For example, when you have stretches of road that are, for some reason, you don't want, because it's already damaged, or you are fearing a big damage, you can say, in this stretch of road, the driving speed should be lowered, for example. You can also influence wandering, which is of impact on the road infrastructure. You can say something about the number of trucks in the platoon configuration, and last but not least, there is the loads of the trucks. All of this is more organized when you're driving in platoons instead of individual trucks, and more organized means that you can influence or steer better your impact on the infrastructure. And a specific case here is the tunnels. We had some nice conversations with the owners of the Mont Blanc tunnel, as you know, a big tunnel between France and Switzerland. And at the moment, there are current regulations for trucks that they have to drive with a huge gap for safety in between them in the tunnels, because it's safer, but it also leads to well, not a lot of trucks in the tunnel at the same time. So when we have platooning and the trucks are safely communicating between each other. And because of that communication, as I already said, you can ensure that they're driving safely behind each other. You could increase the efficiency of a tunnel by allowing more trucks with the safer distance in the truck. So there you can decrease the long time gap in a safe manner, which means there's also a business case for the tunnel and a better efficiency to have not the waiting trucks, but more trucks in the tunnel at the same time. So platooning has a big relationship with infrastructure and a way to influence that. The last part is what we did ensemble for the standardization. So, as I already mentioned in the beginning, we did contribute at the moment during the project already to standardization. We have developed this platooning protocol, which fits the already existing ecosystem of the ITS protocols that are there. So very practically, we have contributed to the certain ISO standard, which is called Intelligent Transport Systems, Truck Platooning Systems, Functional and Operational Requirements. You can also see in the picture a copy of the bibliography, and that there are lots of ensemble inputs there. And we've contributed to a specific ETSI standard, technical report on intelligent transport systems, platooning pre-standardization study. So the platooning protocol developed in ETSI will support both the platooning support function, as I said, but also the work further done for the autonomous function. So in that way, it literally paves the way here for having this protocol also ready when we are going towards this autonomous function. I think it's very important that in Europe, because that's the basis for multi-brand platooning, all truck manufacturers accepting working according to the same standards. Then I come to my main conclusions. Wrapping it up, I think I can, as a coordinator of the project, I can very proudly say that multi-brand platooning has been made possible. We have specifications and requirements agreed by the 7 different European truck manufacturers. We made this iterative process in the project to ensure safety, and we have taken into account a broad set of use cases that the platooning protocol takes into account. We have also included that cybersecurity features that I talked about with you. We have done the inputs to the standardization bodies. And of course, on top of that, we've proven that it works on real roads after the real implementation. The next step left for the last couple of months of the project is to finalize actually our other impact studies that we're still doing of the impacts of platooning, and to also finalize our work on the platooning autonomous function. So that will be a deliverable with also aligned specifications, not implemented yet, but with at least the work on paper, that part has been done at the end of this project. And I'll end my presentation with a short wrap-up of that very great day in Spain. So you will have some images again to see what happened there on the real road in Spain in September 2 months ago. Okay. Let me go back to the last slide. And I think that was my presentation. I give the floor back to our moderator, Jelko.
Excellent, excellent, Marika. Please stay where you are, because now we're going to be probing you with all of the difficult questions. Fantastic work of summarizing the entire work that is extensive from all of the partners and all of the tasks that we have done in the project work packages, etc. What we have just seen is just a glimpse of it. We do have a couple of questions that were coming to us, so maybe it's best just to follow them up directly so that we clarify that. So I'm going to start with an easier one. Marika, what do you mean by wandering? That was a word in the infrastructure impact on platooning slide. Wandering.
Yes. Yeah, wandering is actually the lateral movement of the trucks, and so the wandering is the effect when a truck is driving in a lane. It will drive always in the exact same place. Then it will impact the infrastructure more than instead of just shifting a bit in the lane in its position. So that's the wandering is getting the slopes in your infrastructure actually when driving
so
there.
Adjusting the lateral position within the lane, so to say.
Yes, and normally when trucks are just not adjusting and just always at the same position, it will impact the infrastructure more then.
Excellent.
Yes, it will harm the infrastructure. Yeah.
Great. Thank you, Marika. Can I just ask all of the other experts and panelists maybe to join us, because now we are getting more and more questions and it's time to follow up on them. So let me just get up the right panel here with questions. Okay. There we go. So we received the first question was, I understand that the new shared key is generated every time the platoon configuration changes. For example, truck joins or leaves for any reason. Is that understanding correct? And I guess this is probably a question either for Marika or for Jost.
I can say something about that. In terms of the details, it's slightly different. When the first two trucks join, a unique shared key is defined, and that key remains active for the full session in which the platoon is active. So, for example, if the third truck joins, it will be informed of that already present shared key, meaning 3 trucks will have the same shared key, and that provides the possibility for the trucks to listen into the messages sent by all the other trucks. Now, when a truck leaves, and that's where this thing perhaps goes wrong a bit, you can imagine, if a truck would leave, then it would still have knowledge on that previously used shared key. So in case of a truck leaving, the key in the existing or in the remaining platoon will be updated to make sure that the truck that has left can no longer interfere.
Excellent, many thank you. Maybe I can just add on to that, because there's a follow-up question that is very much linked to that. In the second video, we saw a car that came in between the 2 trucks. How did the trial respond to that? Is one of the questions from one of our answers. Shall we maybe take Eduardo for this one?
Yes, good morning. So a cut in the platooning support function is basically, first of all, detected by the front radar that basically always assess if the information that are coming from B2B are actually coming from the vehicle in front. And if not, then this means that there is an intruder in the platoon. Then if this is happening, then the ego vehicle that detects the intruder in front of him automatically enlarge the gap, because it needs to respect the SCC distance, and this means that it will slow down in order to maintain a safe gap with the vehicle in front. So this is how it has been handled also in the demonstration and during the tests. But the communication from B2B is still kept on for a determined duration. Then if it is a long cut-in, we might end up with splitting the platoon, but usually this is not happening because cut-ins are usually not very long. So that means that the platoon then will close again the time gap and the distance between the two vehicles once the intruder goes away.
Excellent. Many thanks, Eduardo. And on all questions, if there's anything that our other panelists would like to add, please feel free to jump in to have a lively discussion. The next question from the audience is, can you tell something more about the strategic layer? And for example, where is this physically located? What are the message contents exchanged between strategical and tactical levels? Who would like to address this one? Delia, maybe?
Yes, well, that's more on organizing the platoon. I think the work has been done on that, so on platoon finding and what are strategies there. But that will be presented actually in the next big meeting, our final meeting, if I'm right, Marika.
Yes, yeah. And I can say maybe a little bit more because, but yes, it will be presented there. But for example, what we did on this strategic and services layer is the very important platoon matching strategy or algorithm that we made. So that is actually the information that you need to send out and to receive on this strategic layer when you are a truck that is platooning capable on the road, and you want to form a platoon on the fly. So as already was explained with the exchange of messages, etc., how that works on the lower level, you first you're driving there and you thinking, hey, who else is here in my surrounding that goes almost the same direction and I can drive with? So that's a matching procedure, and that is something that a service like a matching service that you just can arrange for you. So that is the kind of information that to know who is in there, also what the loads are of those trucks. So depending on the load, it might be worthwhile doing the platooning together for a certain part of your trip or not. So there's also a monetization part in there, because it's nice that you have this platooning capability, but in the end, it would be good if you have some monetary benefits from that. And that's, of course, for every fleet owner, I think, very important. And I think platooning can give you a monetary benefit, not driving on your own, but sharing a part of the ride with the trucks in your surrounding that go in the same direction anyway. So that is part of this interfacing on the strategic level, trying to decide if it's feasible, possible, and gives you a benefit to join with whom in your surrounding.
Excellent. Many thanks, Marika. And then, of course, you mentioned monetary benefits. Of course, that is very important for all of the fleets. We also have a question. What are results in terms of quantified benefits on CO2, safety, environment? We also spoke about the improved infrastructure use. So shall we maybe start with Francisca, who can tell us a little bit about the work on the impact that she has done, and then we can also let other colleagues fill in where needed.
Yeah, thank you, Jacob. In fact, the question is quite difficult. Indeed, in the work package called Work Package 4, we have assessed, or we are still assessing, the impact of platooning, multi-brand platooning on several domains. You talked about infrastructure, you talked about CO2 emissions, you talked about environment, you talked about benefits for the fleet owners, for the carriers, and so on. So right now, this work is still ongoing. We have already some results, but work is still ongoing. And in particular, if we talk about emissions and we have the results of the test, the Spanish test, and we are still working on it. So we have some results, but I'm not sure that they will be translated in a monetary way at the end. We will have values, maybe even indicators, but not monetary values. So I don't know if that answers the question.
In my opinion, it does. There's still more work to be done, and I know that we are also going to, like in many projects, end up with a very detailed report summarizing all of the findings, especially on the benefits and also costs, business models, etc. So, and I know that work is still kind of being finalized. So, Marika, probably this is one of the things that is going to be one of the outcomes of the final event, so to say.
Yes, for sure, yeah. And
excellent.
There will be results, but not. Yeah, so we will have a lot of impact results, but of course it hasn't been there in the real world. So real measurement is not possible. But we have done some studies on it at least. Yeah.
Indeed, and as you rightfully mentioned, Marika, previously, it is also very much down to the distance that we allow to drive on European roads. We do also know that there's a lot of testing also done by our US colleagues on this, both on the private side, but also supported by US Department of Transport. There they are estimating and measuring benefits of between 7 and 10% of fuel savings, as an example, but they're driving also with much shorter distances. So this is work to be continued, not only by us in Europe, but also on other continents as well. And this is also coming to an interesting question here. One of the colleagues from the webinar is asking, so which European countries are ready to allow truck platooning tests on open roads, both as a support and as autonomous function? Where are we allowed to drive? Eduardo, maybe you or Marika, maybe?
Maybe I can say something about this. At this moment, for example, for our tests in Spain and also the public demonstration in Spain, you need to ask first the local authorities or the regional authorities or the authorities from that country. So there's no country in Europe that you don't have to ask first, and that asking is an official process. So at this moment, that's the situation. Every country wants you to apply for with your platooning capable trucks to apply for an approval, or you can call it an exemption, to drive on their roads. And it depends a lot between countries how that application looks like. It can be just a question and they say, yes, please go ahead, or it can be thousands of forms, or it can be, well, everything in between that. But since the support function is very much in line with at least the basic safety regulations that we have in place, with the driver still being responsible, we as Ensemble think, and the process of asking Spain proved that, is quite simple actually. So in Spain, we have the experience that it's not that difficult. You will get your approval quite soon for the support function.
Okay, excellent. Many thanks. And this is also, of course, also one of the things that we need to see. Is this going to be harmonized in the next steps on the European level? This takes time. I would just like to go over and ask one question considering the standardization. So Marika mentioned that we have been using the ITS G5, but that 5G would be possible as well. I would like to ask Katrine, who is not with us with the camera. Katrine, is that absolutely possible? I mean, what more work do we need to do in order to make it work with cellular technology such as 5G as well?
I mean, so we have been working with peer-to-peer communication in the platooning case here for exchanging control data. So there is also two other ways of doing that, two new radios, one under the 4G framework, which is called LTV2X, and we also have 5G new radio V2X. And so we have developed the protocol itself is of course situated on the facilities layer, so it's quite far away from the radio, and it's sort of technology agnostic. So it is just more a matter of testing with a new technology. And when you go to real hardware, on paper it looks much easier than it is to test on real hardware. So it's merely a testing of a new technology to see, if we have the same latency times and so forth. So but yes, but in theory, of course, we can use another V2X technology. I think it is for now. I mean, the focus is really to have peer-to-peer, so there is direct communication between the vehicles in the platoon, that we are not depending on for the control data to be under the network coverage, I would say. So peer-to-peer, it's essential, I would say.
Great. Thank you very much, Katrine. Follow-up question. So we heard very positive signs from both Marika, but also from other parts of the project, that now we have had the leading truck OEMs working together on defining the standard. How much are we away from this becoming, let's say, officially standardized in different standardization bodies? Question for you, Katrine, or for Peter as well.
Yeah, so I mean, in essence, we have done a lot of great work inside the ENSEMBLE project, and we have one specific deliverable, 2.8, which we are currently updating with the latest, which is really outlining the protocol itself that can fit into the ecosystem in Europe that we have with the other protocols. And I would say that, I mean, the plan now is to open a new work item in ETSI at the next ETSI meeting to do a technical specification. And standardization in ETSI is contribution driven. So we can be really quick on having a TS. We can have it at the end of next year. It depends on, but I think we have done so much work inside ENSEMBLE, so we could be reasonable quick on this one. We are not starting from a blank sheet, so to say. So we can, but this is for the, then you have other things like, you know, functional safety and other stuff that might need to be revisited maybe from standardization point, but from a communication point of view, we can be really quick here.
Very good. And we know that Peter Schmitting from our side, from Vertical side, is also working very closely with ETSI, but also other standardization bodies to really push through this. So Peter, we also know that standardization sometimes can take years, depending on which standardization body. End of next year for the communications protocol in ETSI, are we ready to push for it that fast? Do you see the possibilities?
Well, yes, ETSI is quite dynamic for standardization. Basically, if you have a new work item, you only need 4 supporting organizations that support your idea, and then you can go really fast. If you go to ISO, it's a bit different because it's a more complex process with ballots and national votes, so that can really take years. So, but I think it's a good choice to go for ETSI, because then you can get, as Katrin rightly said, you can get something published within a year.
Very good. Thank you, Peter. We count on you to continue pushing for the standardization in these bodies, ETSI and all of the other ones. If you allow me, I would just like to jump over to Joost, because when I was listening to the presentation from Marika, Marika was explaining the difference between the CACC and ENSEMBLE platooning support function. Joost, can you tell us a little bit more about that? Because I think that there's a lot of additional information on the differences. What's different between these two?
You can say that CACC is in that sense an extension of ACC, and it's using standards-based messages, CAM messages, to exchange information and to improve the ACC behavior of each individual vehicle. Now, when working towards a platoon, we have dedicated platoon control messages that actually close the control loop between trucks. That means we're exchanging much more detailed information on a much more higher frequency to make sure that we can drive constantly at a safe gap and also at a constant gap, so you don't get those harmonica type of effects. And also you can brake in an orchestrated manner even when you are driving at a close distance. So this protocol is also looking forward to be used in the automatic function as well when the gaps get closer and safety aspects become much more important.
Great. And your safety is very much related to trust between the vehicles. So what did ENSEMBLE do basically on the trust side when it comes to communications?
Yeah, trust side is we're basically actually using the authentication mechanism that is already present in common ETSI messages. So each vehicle has a certificate, and using that certificate, each message can be signed, and the receiver of such a signed message can verify that certificate. And if that verification is okay, the receiver basically knows two things. The message was sent by a trusted source, by somebody who also has such a certificate, and the message was not changed. And that is, let's say, the basic level of trust. What's new within ENSEMBLE is, let's say, the aspect of encryption, and thereby using this shared symmetric key, and we discussed that briefly before. You make sure that no other, let's say, vehicles around it can eavesdrop into the messages, but to some extent that also provides a level of authentication, because only the participants that have this shared key can send and receive these messages.
Many thanks, Joost. Eduardo, you have been a little bit of not a little bit, very much also in the center with the rest of the key group here of getting the alignment between the different stakeholders. I mean, how much time is, for example, it's taken to agree on common specifications or what needs to be done in ENSEMBLE, but everything else? Can you tell us a little bit about that?
Yes. So the discussions that we had in work package 2, which is the one that defined the two levels and therefore then the use cases and the requirement and specification. This discussion have been very much facilitated by the layers concept, the one that Marika showed in the slide somewhere. It will come. This layer concept really define what is OEM specific, as Marika said before, and what is common. And the common part is the one that ensures to have the communication between the trucks of different brands, so multi-brand communication. This way to clearly define what is closed, what is OEM only specific, and what is common, for sure facilitated the discussion and therefore the definition of the levels and the use case and the requirement and specification. Nevertheless, let me also anyway thank the suppliers and the OEMs which participated in the discussions, because this discussion have been very much efficient and cooperative. In a very cooperative way, we defined these new two levels of platooning.
Thank you very much, Eduardo. I would just like to go back to a couple of more questions from the colleagues in the audience. You mentioned that gap may be decreased up to 0.3 seconds. That may sound very short and requires different architectures than advanced ACC. What safety architecture do you follow then?
Yeah, I can take it. So we need to be careful. If we can go to the slide where we define the two platooning levels. So the level that has been demonstrated is the support function. In this level, we kept the ACC distance, which is more or less 1.5 seconds. The second level is the one that we just defined and not demonstrated, not implemented. And is a sort of vision of ENSEMBLE for the future of platooning, going towards automation. And in this case, yes, if you are able to remove the driver from the loop, so this means that the system becomes then responsible and you don't rely on the driver as the fallback, this means that you can get closer in a safe way because the system reaction is obviously quicker and faster. Nevertheless, indeed, you need some safety mechanism that we are now defining, because this second level, the platooning autonomous function, will be further detailed and presented in the final event in March 2022. So the only recommendation that I can give is to follow the final event to discover all the findings that we have for this level.
Thanks again. Now, a question to either Marika or you, Eduardo, again. In the videos, the distance did not seem to be between trucks. They did not seem to be uniform. Are the platoon members, so the different trucks, allowed to select their individual distance?
Yes. Being the system based on ACC, the driver can manually adjust the distance with respect to the truck in front. So yeah, the answer is yes.
Great, thank you.
But there is this minimal distance that they need to keep. So they can increase it. They can't go lower than the minimal distance of around 1.4 seconds.
Indeed, and that's the one that we are talking about decreasing in the future to down 0.3 as the minimum distance between the trucks.
And also in the video, you might have seen that it increases because there is a cut-in vehicle. So it's not only because the driver thinks it's more safe to increase in a certain situation, but also the truck reacts to a cut-in that is there. So there's also a safe distance there to the cut-in vehicle.
Thank you. Delia, whenever I listen about these projects or whenever I participate, I'm always amazed about two things. Well, first thing is, how much did we drive with the truck platoon in real life? And the follow-up question as well is, what has been the most difficult things to realize in real life from the implementation point of view?
Well,
easy questions.
I asked the OEMs how much they drove. Let's see, I think just in Spain. So that was track testing and also public road testing, and that adds up to around about 2,000 kilometers in total. And that's not all the testing we did before. So the mono brand and the dual, triple, quadruple brand testing. So only the 3 weeks in Spain was good for 2,000 kilometers of driving. And what was your second question? Oh, what we ran into? Well, some things were really implementation based. So there was a element defined like platoon ID in the platooning management message or in the platooning control message. So what to put in there, what number? And it's nice that we have an idea, but now that we implement it, something should be in there. So that's a very basic thing. Other things were like switching on signing and verification turned out to be quite heavy for the communication units. And if you then also have, for instance, logging on in the communication units, sometimes that was too much, and you get quite strange behavior. And then it's like, yeah, where is the error? How does this? Why does this happen? Some other things like already in building up the trucks, discussions on use cases, what to do when the driver hits the brake. Should this vehicle do a complete leave from the platoon? So if it's in the middle, it leaves the front and the rear vehicle, or should it just make a split, for instance, to make place for an joining vehicle on the highway? Other things, aligning of time. So aligning the time in the trucks to be able to follow who is in front of you. So match the communicated message to your onboard sensor objects. I've got a lot more.
Definitely, I'm very certain there's going to be a long list of lessons learned and the challenges overcome. And
maybe one challenge that's maybe the biggest one is really looking into when to update certain fields in the message. When a vehicle joins a platoon or one platoon joins another platoon. because then the platoon gets longer, the vehicles might get a new position in the platoon, and when to update that, along with also updating, for instance, the encryption key. Should we wait until the encryption is running, or can we already update? Things like that.
Excellent. Thank you very much. Franziska, these days we are talking very much about infrastructure, and of course, you know, everything from the US and Biden's Build Back Better plan to the EU Green Deal, which is also addressing the infrastructure. So can we see from the impact assessment that we have done that actually having a communication between the trucks and ensemble type of truck platooning, is that actually positive towards the infrastructure compared to just having trucks driving on the roads as they do today without any coordination between them?
Well, the answer is yes, of course. So indeed, that's what already Marika told before, but the first deliverable of Work Package 4 will also show that, meaning that if there is communication between vehicles and infrastructure, there can be a collaboration. Meaning on one side, we can try to optimize the driving of the vehicles on trucks on the infrastructure in order to minimize the impact, minimize the damage or the wear, let's say the wear of the infrastructure. And on the other side, we can also think that it can be a win-win situation, meaning that if we have this collaboration, it means that there is shared information, and there can be, for example, allocated slots for trucks or allocated slots for platoons and so on. So I think, and not only me, let's say, CEDA, for example, also thinks that there can be a collaboration between vehicles and infrastructure in order to have the best situation for both actors in that.
Great, many thanks, Franziska. Very good. We have another question here. We have performed platooning trials in Norway and Scania with Scania trucks. We struggle with string stability in winding curves and steep uphill and downhills. Did you encounter anything similar during your field trials? So did we notice, for example, difficulty with the positioning of trucks in uphills, downhills, winding curves? And follow-up question as well. I know that we have been working on tunnels. Do tunnels pose a difficulty itself? So all of these are kind of, well, I will not call them extreme, but more unusual situations. Who would like to take that?
I can jump in here. Well, string stability is a known problem. It has also been seen in powerful cars with ACC. I've been a lot in the trucks while testing on a test track, but I have to say that the test track is of course very flat. So, but we did not notice any instabilities there. We're still looking into the data from the road tests. It was not visible directly on the videos, as you also saw, but we still have to really look into the data for more details. And tunnels, yeah, first of all, the big problem with tunnels is there's no GPS connection in there. Well, in most tunnels, I heard some tunnels do have some devices there. And when you do not have a GPS position and timing very right, then yeah, matching the messages to the objects gets difficult again. When you have a platoon already, when you're already platooning, when you enter a tunnel, you might continue doing that unless you detect that there is a cut-in vehicle. For instance, your radar sees a switching of the object you're following, and then making a new platoon in the tunnel is difficult. Sometimes also communication units cannot function very well when in the tunnel and no GPS is available.
Great. And maybe just to follow up on that, there's a couple of questions that are quite similar, and I'll just bundle them up in one. How to absorb, coordinate the difference of each truck's braking ability in the platoon?
Well, first of all, there's two things. We communicate the intended braking of the truck, so the way how much the truck is going to brake, and the actual acceleration of the truck. So that can be taken into account by the following trucks. And really, when you look into, maybe this is what the question is about, the maximum braking capacity of the trucks. That is something that is still open and to be further investigated, because a lot of parameters are involved there. So you have the truck itself. You have trailers that can be anything. Yeah, you cannot. You can control maybe your truck, but you cannot control what is behind the truck. The road condition, tire condition, brake condition. So the brake wear, etc. So that's really a very interesting but still not solved topic. And it's especially looking towards the platooning autonomous function going to be, needs to be solved when you want to go also to smaller following distances. Now the driver can do a short quick test on and experience what the brake capacity is. And he sees also the condition of the road, the weather condition, and can adjust the following distance to that, just like they do today and should do today. But for the autonomous function, there's no driver in the following vehicles, and you need a good estimation for that, the maximum braking capacity.
Indeed. Many thanks. We are actually coming slowly close to the end of the webinar, and we still have a number of questions. I will just try to take a couple of questions of the type that have maybe not been asked before. Marika, I would like to ask you this question. Which type of organization could be in charge of platooning organization, let's say, or monitoring in the future on either national level or international level, so to say? Or European level. This is very much down to business modeling. This is very much down to exploitation plans. Who would need to coordinate the truck platoons?
Is that then the coordination of the actual, so to get them on the road and to have them in platoons on the road? I think that's the question. The coordination there is, well, it starts, I guess, with Europe and the European countries to welcome the platoons, to see that this is the way forward for a certain number of benefits that the countries can have from platooning. But if that's done and they're welcome on the roads, I think the actual organization of the platoons on the road can be done in that strategic service layer, which in the end can be a service provider like we have now for the navigation systems, for example. They provide another service that helps and steers the fleet owners to become a part of this on-the-fly platooning, because that would be the ideal world. You don't have to organize your platoon when you're still at your base with the fleet owner and being part of the whole planning there. No, you can just go on and have it on the fly and make advantage of whatever is possible there on the road. And so I guess that it looks like a whole organization, but in the end, it's just a service that you hook onto, like you choose a navigation service.
Indeed, and just
in the end,
just to follow up on that, in my understanding, one of the functionalities or one of the services offered by this service provider would also to potentially balance the benefit, because depending on who is driving, if you're first or second truck in a platoon, you're also getting different, so to say, fuel saving benefits in the future. So that would also potentially need to be balanced.
Exactly, and that can be part of that service or a next one, where you just subscribe to that service, and then depending whether you're number 2 or 3, you're at least that service divides the monetary benefit over the trucks, I would say. So that's like you join and you receive some from that service.
Excellent, excellent. Very good. So I'm going to ask all of the expert panelists in a couple of minutes just to kind of help us wind up the discussions. Maybe with just the final statement, if you have missed something that is important that I would like to highlight, or maybe to highlight some next steps that we also need to think about, that is going to be very brief. So think about it. It's a surprise, not prepared. So think everybody about, you know, do we need to lift something up more than what we have said today, and potentially next steps? Very brief answers, please. Now, I would just like to address a couple of other questions from the audience. Very small, very organizational question. Could we get a list of participants after meeting? And no, due to GDPR, we cannot give you the list of participants, but we can provide a list of companies that have participated, so to say, in order to comply with GDPR, potentially, for sure. At what distance were the vehicles driving during the demo, or is the analysis of the distances for fully automated platooning? I believe, Marika, you already answered that by stating it was 1.4 seconds, right? Between trucks?
But maybe you want to, so the distance in meters then depends on your speed when you talk about distance in seconds. But that corresponds when you're, well, the trucks drive around 80 kilometers per hour. It corresponds to 40 meters or something, 35. Yeah. To get the
excellent.
Yeah.
Now that said, I believe, and if I've not made a mistake, we have gone through all of the questions from the audience. There were some questions that were quite similar, so I didn't ask them 2 times. And I hope that everybody in the audience is also happy with the answers that they've got. Now, starting with maybe Katrien and Peter, is there anything else that you would like to highlight on standardization, or anything that you would like to state as the next step, next actions, within 1 minute, please, or less, few sentences?
Oh, so this is Katrin here. So I think, we have a pretty clear plan of what we would like to do in standardization, and now it's just time to start to work. So yeah, I look forward to start this work in ETSI and get feedback from also other stakeholders outside the ENSEMBLE project.
Well, yes, from my side, not much to add. I will also follow the ETSI standardization, and will also see what's happening at ISO level in that area of platooning and so on.
Excellent.
That's all from my side.
Thank you both. Thank you, Katrien. Thank you, Peter. Franziska, we know that you have a lot of work still to be done, not only you, but the entire consortium on the impact assessment. Would you like to highlight some additional topics, or?
Yeah, well, as you said, there are already a lot of results on impact assessment, and they are very interesting. So I would say it would be I would invite everyone to come back to listen to the result afterwards. And I did not go here in detail because it would only lessen the impact, meaning the results. There are a lot of impacts and many details to be said about it.
Excellent, excellent. And we look forward to learning all of the details in the reports, but also in the future communication. Delia, congratulations on overcoming all of the technical challenges. Tell us, for you, is it what are the next steps? Now it's
well, next steps from a larger point of view. So really trying to get this platooning support function to the road is testing. So really get more testing, get more experiences, and check out if the things work how it should work. What still didn't we forget about something? And more to the details. Well, like I said, brake performance estimation, and also positioning. So being able to really pinpoint, have precise positioning, more than just a GPS, simple GPS position, to be able to really know who you're communicating with, And it's not only for platooning, but also for all cooperative systems, very important.
Indeed. Thank you very much, Delia. Jost, considering the communications, what can we say there? What are the next steps?
Well, I'm personally interested in two aspects: is the step up towards the autonomous function. What is the impact of that onto the platooning protocol? Basically, meaning is the first version sufficient to add some things on top of that to work for autonomous as well? And the second aspect is in the direction of standardization more, since the platoon control messages will be the very first message type that uses encryption. And I'm very curious to find out how the organization like ETSI looks into that topic, having encryption in.
Excellent. Thank you, Jost. Eduardo, when it comes to specifying the functionalities of the truck platoons for the future, same question for you. What would you see as the next steps? And did we maybe miss to highlight something important in this discussion today?
I think the most important thing to highlight is that we really been able in ENSEMBLE to bring monobrand platooning to multi-brand platooning, which is very, very important. And inside ENSEMBLE, we are finalizing the definition of the platooning autonomous function that will be presented in the next event, including the safety analysis, both from the HARA and the SOTIF, so the two big ISO's standards for safety analysis. So we will present all the results also for this second level in the next event. And again, I reiterate my recommendation to follow that, because we achieved some very good results with the support function, but also this second level, this outlook for the future, it will be very much interesting.
Excellent. Many thanks, Eduardo, and all everybody else. Finally, Marika, as the coordinator, where next? Should we highlight something more that we haven't highlighted today? Because it's been 90 minutes, but it's been still very short time considering the amount of discussions that we have had.
Yes, exactly. But still, I'm happily surprised to see how much we could still discuss in this 1.5 hours, and at least the main important things I think have been said. I can add two things, because and just following up on what Eduardo said, there's two things that need to happen after ENSEMBLE. So that's already in a couple of months. And the first thing is that the support function is now ready to try out and make the connection with the real world, because it was now in the project. And of course, we did a lot in the project, but the real world is out there. And the real world, I mean, fleet owners, looking at the discussion we had about how are we going to meet and match, etc. So that would be great to implement some of it as a next step already after the project, to look at real world effects. And the other one is the autonomous function. Also after the project, I think this is a main result that we will further see, maybe not the next months after the project, but it's a huge step towards what all of the OEMs are working on, and that's more autonomous driving in general and autonomous platooning specifically. So when maybe even after only 10 years you see autonomous trucks, you should remember there's some ENSEMBLE based on that after 10 years.
Excellent. And I think that is a really fantastic statement to wrap this up. It has been absolutely a pleasure to moderate, and very easy to moderate this webinar, because the audience has been very active. We should again thank all of the partners, not only us that are here visible with cameras and that are answering the questions, but this is really work of the entire consortium. Everybody has worked hard and well. We absolutely have to highlight also support from the European Commission, which has enabled us to cooperate here during the past couple of years. That is very important. And of course, we would like also to continue engaging even after this webinar. Please reach out to any of us or to all of us if you have any follow-up questions. As Eduardo also highlighted, please also come to our next event as well, where we are going to be talking much more about the results. And finally, you know, we are all excited about technology, but again, we are all here to work for improved Vision Zero, reducing road fatalities, for addressing the climate change and addressing the targets of the Green Deal. And this is also what is making us all excited with the truck platooning and the ensemble work. It is not really about just technology, it is what technologies can give us as real life benefits. Fantastic work done up to now in ensemble. It is not finished yet. There's a lot of days and nights to be worked. And I would just like to thank all of the participants in the project and in the audience. Thank you so much, and I wish you a very nice rest of the day. Thank you.
Thank you.
Bye.